we are going to begin looking at systems of equations and how to solve them. And in today's notes, we're going to look at the method of graphing to solve a system. So a system of equations is just two or more equations, and that's called a system. And the solution to a system of equations, if we use graphing as the method to find the solution, is a point that makes both equations true. So it's an ordered pair, an xy pair, a single point that makes both equations true. And so to do this graphically, the goal here is to find where these two equations intersect. So we're going to be graphing them both on the same coordinate plane and just finding the point where they cross. So the first example here, we have two equations, y equals negative 2x plus 1 and y equals negative 1/3 x minus 4. So we're just going to graph these both and see what happens. So the first one, negative 2x plus 1, we start at 1 on the y-axis. Slope is negative 2, or negative 2 over 1, so that's down 2, right 1. Keep going. It's really important, especially on this lesson, that you bring the line all the way across the graph so you can really see where the two lines intersect. The next equation is y equals negative 1/3 x minus 4. We're going to start down 4, down 4 this time. Slope is negative 1 over 3, so down 1, right 3. We're up and left. And we can see where they're going to cross. All right, so these two lines intersected right here. So this is the solution to the system. So we just have to name this ordered pair. And that is the ordered pair 3, negative 5. And that's the solution to the system. If we plugged in these values for x and y in both of these equations, they would make both of the equations true. Example B, y equals negative 3 over 2x minus 4, and y equals 1/2 x plus 4. So let's start with the first one. Down 4 on the y-axis. The slope is negative 3 over 2, so down 3, right 2. Kind of off the graph on this first one, so we can go backwards. Up 3, left 2. Do that a few times. So there's the first line. And then we have 1/2 x plus 4, so start up at 4, up 1 over 2, or down 1, left 2. And here's the solution right there, which is the point negative 4, 2. Again, we're just graphing both lines and seeing where they cross. Now, not every pair of equations will cross, and not every pair of equations will cross at a nice intersection like this, but for these notes, these are all set up so that they get a nice clean solution. All right, y equals negative 3 for part C, and y equals negative 3 over 2x plus 6. Remember, y equals negative 3 has a slope of 0. So we go to negative 3 here, and then the line is just horizontal. And then y equals negative 3 over 2x plus 6. We start at 6. We're going to go down 3 over 2 to right there. Right on the edge, which is the point 6, negative 3. This point right here. So it is important that, especially for situations like this where it's right on the edge of our graph, it's important that you make sure you draw clearly, try to stay as straight as possible, and that way you can really see where those lines intersect. Example D, y equals 4 and x equals negative 2. Well, again, y equals 4 is a slope of 0, so horizontal, just like this. And x equals negative 2, remember this is a vertical line through negative 2 on the x-axis. So the point right here where they intersect is actually pretty simple because it's negative 2, 4, which if you look at the equations, match up with those x and y values. So that one's pretty straightforward there. They cross at the point negative 2, 4. moving on to example E, we can go ahead and graph the first one, which is y equals negative 2/3 x plus 1. So we'll start at 1. We're going to go down 2, right 3, up 2, left 3, and make our line. Now for the second equation, we do need to solve that one for y because it is not in slope-intercept form yet. So let's go ahead and get it there. We're first going to have to move this 2x by subtracting it. And remember, you can't subtract 12 minus 2x because 12 doesn't have an x on it. So we're just going to write that out as negative 2x plus 12. We're doing it that way instead of 12 minus 2x because we want our equation to be in slope-intercept form, which is y equals mx plus b. So the x term needs to come first. All right, last step, divide by 3. So we have y equals, now this you can leave a fraction, negative 2/3 x. 12 divided by 3 is 4. And so there is our equation. So up to 4 here, and then down to over 3. Now something you're probably noticing on this problem is that our lines are parallel. They have the same slope, negative 2/3. So these lines do not intersect. They're parallel. So since we're looking for the point where the two lines intersect, this problem actually has no solution because there is no intersection point. So there is no solution here. So if you have parallel lines in a system of equations, they will not have a solution because they do not intersect. We'll probably see something similar here if I was to guess, but let's find out. So this first one we do need to solve for y. Let's go ahead and do it. 6y plus 2x equals negative 24. We're going to go ahead and subtract 2x. Same reasoning as before. Can't combine these numbers because one has x and one doesn't. So we're going to write it out as negative 2x minus 24. Okay, next, divide by 6. So y equals, now this negative 2 over 6 we can reduce. We can simplify that to negative 1 over 3. So that's what we'll use for our slope here. And then negative 24 divided by 6 is negative 4. So let's go ahead and graph that. We start down here at negative 4, down 1 over 3, or up 1, left 3. And there is the line. And now let's go back and graph that second one. Y equals negative 1/3 x minus 4. Well, that sounds familiar. Down 4, and then down 1 over 3. This ends up being the exact same line. And since we are looking for the point where the two lines intersect, these two lines actually intersect at every point possible. So there are infinite ways that these two lines intersect each other because they're right on top of each other. So this problem has infinite solutions because those two lines are the same. So there are your two special cases. If you've got parallel lines, there is no solution. If you've got the same line, that's infinite solutions.